The Spring Framework is an open-source application framework and inversion of control container for the Java platform. The framework's core features can be used by any Java application, but there are extensions for building web applications on top of the Java EE platform. Although the framework does not impose any specific programming model, it has become popular in the Java community as an alternative to, replacement for, or even addition to the Enterprise JavaBean model. Version history: the first version was written by Rod Johnson, who released the framework with the publication of his book Expert One-on-One J2EE Design and Development in October 2002. The framework was first released under the Apache 2.0 license in June 2003. The first milestone release, 1.0, was released in March 2004, with further milestone releases in September 2004 and March 2005. The Spring 1.2.6 framework won a Jolt Productivity Award and a JAX Innovation Award in 2006. Spring 2.0 was released in October 2006, Spring 2.5 in November 2007, Spring 3.0 in December 2009, Spring 3.1 in December 2011, and Spring 3.2.5 in November 2013. The current version is Spring Framework 4.0, which was released in December 2013. Notable improvements in Spring 4.0 include support for Java SE8. Groovy 2, some aspects of Java EE7, and WebSockets. Modules: the Spring Framework includes several modules that provide a range of services. Aspect-oriented programming enables implementing cross-cutting concerns. Authentication and authorization: configurable security processes that support a range of standards, protocols, tools and practices via the Spring Security sub-project. Convention over configuration: a rapid application development solution for Spring-based enterprise applications is offered in the Spring Roo module. Data access: working with relational database management systems on the Java platform using JDBC and object relational mapping tools and with NoSQL databases. Inversion of control container: configuration of application components and lifecycle management of Java objects, done mainly via dependency injection, messaging, configurative registration of message listener objects for transparent message consumption from message queues via JMS, improvement of message sending over standard JMS APIs, Modella Viewer Controller, an HTTP and servlet-based framework providing hooks for extension and customization for web applications and RESTful web services. Remote Access Framework: configurative PC-style marshalling of Java objects over network supporting RMI, CORBA and HTTP-based protocols including web services. Transaction management: unifies several transaction management APIs and coordinates transactions for Java objects. Remote management: configurative exposure and management of Java objects for local or remote configuration via JMX. Testing: support classes for writing unit tests and integration tests. Inversion of control container: central to the Spring Framework is its inversion of control container, which provides a consistent means of configuring and managing Java objects using reflection. The container is responsible for managing object lifecycles of specific objects, creating these objects, calling their initialization methods, and configuring these objects by wiring them together. Objects created by the container are also called managed objects or beans. The container can be configured by loading XML files or detecting specific Java annotations on configuration classes. These data sources contain the bean definitions that provide the information required to create the beans. Objects can be obtained by means of either dependency lookup or dependency injection. Dependency lookup is a pattern where a caller asks the container object for an object with a specific name or of a specific type. Dependency injection is a pattern where the container passes objects by name to other objects, via either constructors, properties, or factory methods. In many cases one need not use the container when using other parts of the Spring Framework, although using it will likely make an application easier to configure and customize. The Spring Container provides a consistent mechanism to configure applications and integrates with almost all Java environments, from small-scale applications to large enterprise applications. The container can be turned into a partially compliant EJB 3.0 container by means of the Pitchfork project. Some criticize the Spring framework for not complying with standards. However, Spring Source doesn't see EJB 3 compliance as a major goal, and claims that the Spring framework and the container allow for more powerful programming models. You do not create an object, but describe how they should be created, by defining it in the Spring configuration file. You do not call services and components, but tell which services and components must be called, by defining them in the Spring configuration files. This makes the code easy to maintain and easier to test through IOC. Aspect-oriented programming framework. The Spring framework has its own AOP framework that modularizes cross-cutting concerns in aspects. The motivation for creating a separate AOP framework comes from the belief that it would be possible to provide basic AOP features without too much complexity in either design, implementation, or configuration. The Spring AOP framework also takes full advantage of the Spring container. The Spring AOP framework is proxy pattern-based, and is configured at runtime. This removes the need for a compilation step or load time weaving. On the other hand, interception only allows for public method execution on existing objects at a join point. Compared to the Aspect-J framework, Spring AOP is less powerful, but also less complicated. Spring 1.2 includes support to configure Aspect-J aspects in the container. Spring 2.0 added more integration with Aspect-J. For example, the point-cut language is reused and can be mixed with Spring AOP-based aspects. Further, Spring 2.0 added a Spring Aspects library that uses Aspect-J to offer common Spring features such as declarative transaction management and dependency injection via Aspect-J compile time or load time weaving. Spring Source also uses Aspect-J for AOP in other Spring projects such as Spring Roo and Spring Insight, with Spring Security also offering an Aspect-J-based aspect library. Spring AOP has been designed to make it able to work with cross-cutting concerns inside the Spring framework. Any object which is created and configured by the container can be enriched using Spring AOP. The Spring framework uses Spring AOP internally for transaction management, security, remote access, and JMX. Since version 2.0 of the framework, Spring provides two approaches to the AOP configuration, schema-based approach and, at Aspect-J-based annotation style. Beans XMLNS equals HTTP, www.springframework.org Beans, XMLNS, MVC equals HTTP, www.springframework.org MVC, XMLNS, XI equals HTTP, www.3urgxm schema instance, XMLNS, ORP equals HTTP, www.springframework.org AOP, XMLNS, context equals HTTP, www.springframework.org context, XI, schema location equals HTTP, www.springframework.org Beans, HTTP, www.springframework.org Beans Spring Beans 3.0 XSD, HTTP, www.springframework.org context, HTTP, www.springframework.org context Spring Context 3.0 XSD, HTTP, www.springframework.org MVC, HTTP, www.springframework.org MVC Spring MVC 3.0 XSD, HTTP, www.springframework.org AOP, HTTP, www.springframework.org AOP Spring ORP 3.0 XSD. The Spring team decided not to introduce new AOP-related terminology. Therefore, in the Spring reference documentation and API, terms such as aspect, join point, advice, point cut, introduction, target object, AOP proxy, and weaving all have the same meanings as in most other AOP frameworks. Data Access Framework. Spring's Data Access Framework addresses common difficulties developers face when working with databases in applications. Support is provided for all popular data access frameworks in Java: JDBC, Ibertis, MyBatis, Hibernate, JDO, JPA, Oracle TopLink, Apache OJB, and Apache KN, among others. For all of these supported frameworks, Spring provides these features: resource management, automatically acquiring and releasing database resources, exception handling, translating data access-related exception to a Spring data access hierarchy, transaction participation, transparent participation in ongoing transactions, resource unwrapping, retrieving database objects from connection pool wrappers, abstraction for blob and CLOB handling. All these features become available when using template classes provided by Spring for each supported framework. Critics have said these template classes are intrusive and offer no advantage over using the Hibernate API directly. In response, the Spring developers have made it possible to use the Hibernate and JPA APIs directly. This, however, requires transparent transaction management, as application code no longer assumes the responsibility to obtain and close database resources, and does not support exception translation. Together with Spring's transaction management, its data access framework offers a flexible abstraction for working with data access frameworks. The Spring framework doesn't offer a common data access API. Instead, the full power of the supported APIs is kept intact. The Spring framework is the only framework available in Java that offers managed data access environments outside of an application server or container. While using Spring for transaction management with Hibernate, the following beans may have to be configured: a data source like COM-change v2c3po combo pool data source or org Apache Commons DBCP. Basic data source: a session factory like org Spring Framework or Hibernate 3 local session factory bean with a data source attribute, a Hibernate properties like org Spring Framework beans factory config. Properties factory bean: a transaction manager like org Spring Framework or Hibernate 3 Hibernate transaction manager with a session factory attribute. Other points of configuration include an AOP configuration of cutting points. Transaction semantics of AOP advice. Transaction management framework: Spring's transaction management framework brings an abstraction mechanism to the Java platform. Its abstraction is capable of working with local and global transactions, working with nested transactions, working with save points, working in almost all environments of the Java platform. In comparison, JTA only supports nested transactions and global transactions, and requires an application server. The Spring framework ships a platform transaction manager for a number of transaction management strategies: transactions managed on a JDBC connection, transactions managed on object relational mapping units of work, transactions managed via the JTA transaction manager and user transaction, transactions managed on other resources, like object databases. Next to this abstraction mechanism, the framework also provides two ways of adding transaction management to applications: 1, programmatically, by using Spring's transaction template; configuratively, by using metadata like XML or Java annotations. Together with Spring's data access framework which integrates the transaction management framework it is possible to set up a transactional system through configuration without having to rely on JTA or EJB. The transactional framework also integrates with messaging and caching engines. Model View Controller Framework: the Spring framework features its own MVC web application framework, which wasn't originally planned. The Spring developers decided to write their own web framework as a reaction to what they perceived as the poor design of the popular Jakarta Struts web framework, as well as deficiencies in other available frameworks. In particular, they felt there was insufficient separation between the presentation and request handling layers, and between the request handling layer and the model. Like Struts, Spring MVC is a request-based framework. The framework defines strategy interfaces for all of the responsibilities that must be handled by a modern request-based framework. The goal of each interface is to be simple and clear so that it's easy for Spring MVC users to write their own implementations, if they so choose. MVC paves the way for cleaner front-end code. All interfaces are tightly coupled to the Servlet API. This tight coupling to the Servlet API is seen by some as a failure on the part of the Spring developers to offer a high-level abstraction for web-based applications. However, this coupling makes sure that the features of the Servlet API remain available to developers while offering a high abstraction framework to ease working with said API. The Dispatcher Servlet class is the front controller of the framework and is responsible for delegating control to the various interfaces during the execution phases of a HTTP request. The most important interfaces defined by Spring MVC, and their responsibilities, are listed below. Controller comes between model and view to manage incoming requests and redirect to proper response. It acts as a gate that directs the incoming information. It switches between going into model or view. Handler Adapter, execution of objects that handle incoming requests. Handler Interceptor, interception of incoming requests comparable, but not equal to servlet filters. Handler Mapping, selecting objects that handle incoming requests based on any attribute or condition internal or external to those requests. Locale Resolver, resolving and optionally saving of the locale of an individual user. Multi-part Resolver, facilitate working with file uploads by wrapping incoming requests. View, responsible for returning a response to the client. Some requests may go straight to view without going to the model part. Others may go through all three. View Resolver, selecting a view based on a logical name for the view. Each strategy interface above has an important responsibility in the overall framework. The abstractions offered by these interfaces are powerful, so to allow for a set of variations in their implementations, Spring MVC ships with implementations of all these interfaces and together offers a feature set on top of the Servlet API. However, developers and vendors are free to write other implementations. Spring MVC uses the Java util map interface as a data-oriented abstraction for the model where keys are expected to be string values. The ease of testing the implementations of these interfaces seems one important advantage of the high level of abstraction offered by Spring MVC. Dispatcher Servlet is tightly coupled to the Spring inversion of control container for configuring the web layers of applications. However, web applications can use other parts of the Spring framework including the container and choose not to use Spring MVC. Remote Access Framework. Spring's Remote Access Framework is an abstraction for working with various RPC-based technologies available on the Java platform both for client connectivity and marshalling objects on servers. The most important feature offered by this framework is to ease configuration and usage of these technologies as much as possible by combining inversion of control and AOP. The framework also provides fault recovery and some optimizations for client-side use of EJB remote stateless session beans. Spring provides support for these protocols and products out of the box, HTTP-based protocols, Hessian, binary serialization protocol, open-sourced and maintained by CORBA-based protocols, RMI, method invocations using RMI infrastructure yet specific to Spring, RMI. Method invocations using RMI interfaces complying with regular RMI usage, RMI IOP, method invocations using RMI IOP CORBA. Enterprise JavaBean client integration, local EJB stateless session bean connectivity, connecting to local stateless session beans, remote EJB stateless session bean connectivity, connecting to remote stateless session beans. SOAP, integration with the Apache Access Web Services framework. Apache CXF provides integration with the Spring framework for a PC-style exporting of object on the server side. Both client and server setup for all RPC-style protocols and products supported by the Spring Remote Access framework is configured in the Spring core container. There is alternative open-source implementation of a remoting subsystem included into Spring framework that is intended to support various schemes of remote and convention over configuration rapid application development. Spring Boot is Spring's convention over configuration solution for creating standalone, production-grade Spring-based applications that you can just run. We take an opinionated view of the Spring platform and third-party libraries so you can get started with minimum fuss. Most Spring Boot applications need very little Spring configuration. Create standalone Spring applications, embed Tomcat or Jetty directly, provide opinionated starter POMs to simplify your Maven configuration, automatically configure Spring whenever possible, provide production-ready features such as metrics, health checks and externalized configuration, absolutely no code generation and no requirement for XML configuration. Spring Boot provides an alternative, code generation-based approach at using convention over configuration to rapidly build applications in Java. It currently supports Spring Framework, Spring Security and Spring Webflow. Root differs from other rapid application development frameworks by focusing on extensibility, Java platform productivity, lock-in avoidance, runtime avoidance, usability. Batch framework. Spring Batch is a framework for batch processing that provides reusable functions that are essential in processing large volumes of records, including logging, tracing, transaction management, job processing statistics, job restart, skip, resource management. It also provides more advanced technical services and features that will enable extremely high volume and high performance batch jobs through optimizations and partitioning techniques. Integration framework. Spring Integration is a framework for enterprise application integration that provides reusable functions that are essential in messaging, or event-driven architectures, routers, transformers, adapters to integrate with other technologies and systems, file systems, etc., filters, service activators, management and auditing. Spring Integration supports pipe and filter-based architectures. Criticisms. Spring has been accused of lacking a cohesive philosophy, and instead being an ad hoc collation of sometimes inconsistent current best practices solutions to disparate problem domains. References. Bibliography. See also: Apache HiveMind, Apache Tapestry, Gemstone, Google Guys, Juzu Web Framework, Spring Webflow, external links, Blossom, Spring Framework Integration Module for Magnolia CMS, Spring, Guides and Tutorials, Spring, The Art of Using Grasp Patterns, Spring Android, Spring Batch, Spring Boot, Spring Data, Spring Framework Tutorials, Spring Hatios, Spring Integration, Spring JDBC Template, Spring Mobile, Spring Framework, Spring Security, Spring Social, Spring Tutorial, Spring Tutorials Concept with Spring Examples, Spring Webflow, Spring Web Services, Spring XD, the Spring Framework, reference documentation.